Welcome to my channel. A piece of clay of mass m is dropped on top of a rotating disk's edge of mass 2m, spinning at a speed of omega 0. What will the resulting rotational speed omega be? So this figure shows the rotating disk around this axis before the clay is dropped on its edge. This figure is after dropping the clay. So here what we know is that L, which is angular momentum, is conserved because there is no any external torque applied to this mechanical system. So Li is equal to Lf, initial and final. So before the clay drops on top of the edge, the only moment of inertia that we have in this system is for disk times omega 0 for this system, as you can see. And after dropping the clay, moment of inertia will be the sum of moment of inertia for disk plus for the clay. Times omega. This is final omega, and we are looking for this omega. So I for disk, from the formula that we have for different objects, is 1/2 2m. The radius is r squared. So this is the total mass for the disk. And for the clay, it's like we have an object with mass m rotating about this axis. So we have m r squared. We need to substitute these in this equation. So we get 1/2 2m r squared times omega 0 equals 1/2 2m r squared plus m r squared times omega. So here we can cancel out 2 at left, and also 2 here and here. So we get for the left side, we get m r squared omega 0 equals, for this one we get m r squared plus m r squared times omega. But this is 2mr squared. So mr squared omega 0 will be 2mr squared omega. Now we can cancel out mr squared from left and right side, and then we get omega 0 as 2 omega. If we divide both sides by 2, we get omega 0 over 2 equals omega. So angular velocity after the clay drops on the edge of the disk becomes half compared to initial angular velocity. Thank you very much for watching this video. Please follow my channel for other videos.